can build a replica if you're electronics inclined. And the simplest way is to get the original hardware components, if you can find them. The PDP-8, you can get not the original Intercell 6100 chip, you can get the Harris 6120, which is a slightly enhanced version. And it's a PDP-8 on a single small chip. And the chips to support it, you need 3 or 4 for the serial port and things, but you can get them. I managed. Another way is to build the whole thing from individual components, but you have to be a real masochist for that. Finally, you can use something called an FPGA, a field programmable gate array. Basically, it's individual logic building blocks on a chip, and they're all connected via fuses which you can blow in order to disconnect parts and build yourself a circuit. It's a well-known technique, but you require a lot of expertise for that. I know somebody who's done it with the PDP-11. This is first of all a real PDP-8E, just to show you. The PDP-8E is around 1967, something like that. And you can see it's got lots of nice switches. It's got lights which you can't see, but they're in those 4 rectangles just above the secondary screen. There's a switch there. With that switch you can display different things on the lights, like the contents of different machine registers. So the SBC 6120 is a single board computer using a 6120. That's a basic one. I've got this one. This is mine, and it's just what you've got there is the 2 large chips on the right. The bottom of the 2 is the CPU. The top one is an interface to the outside world, to the disk. The one down the left-hand side, the big one, is the serial thing. The 6 chips there are the memory, and the 2 at the bottom with labels on are the BIOS. That's basically it. And that is a compact flash card, which you used to use in cameras a lot, and that's a hard disk basically. In fact, it's lots of hard disks, because they can only be 2 meg each. So it's only got a power connection at the back there, a serial port for a terminal, a little reset button at the front, and some LEDs. And that's basically it. This is the deluxe version. What that's got in it is a silkscreen panel, obviously made to look like the other one, and behind that is a fairly large board which carries all the LEDs, of which there aren't that many. It's about 25 or something. It's got the switch, and it's got bolted onto that board is the board you saw just now, so it gives you the same thing. So you've got blinking lights now, which is nice. There's a ROM BIOS, as I said, sort of thing, which allows you to do file transfer and allows you to down the serial port, and it also allows you to debug things if you need to. It's running real code on real hardware, so that's a replica. You can use OS8, you can run OS8 on it, and you can compile and run programs in various languages. But unfortunately, the HE6120, they decided to improve it by adding some new instructions. And they collide with the instructions that were used for TSS8. So TSS8 won't run on it, which is a shame. But in all other respects, it's PDP-8E. It looks like it, and it is. So I'll come back to that, because emulation is the third part. And this is possibly the most interesting in many ways, and the most accessible, because emulation can cost you nothing at all. And what you do there is use a newer, more powerful machine to pretend to be the target machine. Now the clock speed of that machine I just showed you is about 4 megahertz, I think. And given that we run, sort of 3.5, 4 gigahertz chips these days, you can see that it's easy to do emulation. Emulation means literally doing exactly what the CPU would do. So it pulls stuff out of memory and does things with it. You emulate the CPU by interpreting instructions that come out of the emulated memory, which is simply an array of bytes, because that's all memory is. The peripherals you emulate in various ways. Disks are fixed-size files, and they've got individual blocks inside them. Tapes can be structured files, because I don't know if you know much about old mag tapes, but they have a thing called tape marks, which are special delimiters, which are not like ordinary blocks of data. And so you need to have some way of doing that, so it's not a simple file. Cards, paper tape readers, punch cards, printers are just files. And terminals are usually multiplexed onto something like a telnet or SSH connection. So you can use your ordinary terminal or a window in your operating system. There's a lot of emulation software available for so many targets you wouldn't believe it. There's a wonderful thing called Hercules, which does an IBM mainframe. which is very, very functional. Pretty well all the deck machines you can get emulators for, all from the same guy. And even the PC you can get an emulator for. Why would you want an emulator for the PC? Well, it allows you to run DOS for a start. You might want to do that for something. Also, there's a thing called DOSBox on Unix, which you may have seen. But also to debug stuff on your PC. If you're writing a new operating system on the PC, why not use an emulator? Because you can single step it, you can do all the usual. So, one emulator system is called SimH. That stands for Simulated History. And it's the most commonly used one for DEC machines, but it's a framework as well. It's written in C, and you can get it on pretty well any system you like. It's not hard to put it on a new one. It consists of an emulator framework, and the framework does a lot of the work for you, and then various emulator programs that are built on top of that framework. So the Altair, remember the Altair? In the background on the IT crowd. Do you remember they had an Altair on the shelf behind him? Yeah, Honeywell 516 and 316, which are dear to my heart because I actually had my final year project was modifying the CPU on the 516. HP 2100 and the 3000 as well. The early IBM machines, the ICL 1900, which was a 24-bit machine, very popular from about 1964 up to about 1980 and there beyond. Interdata, we've gone now. Data General Nova and Eclipse, quite important. All the PDPs, the PDP 1, 4, 7, 8, 9, 10, 11 and 15, all the major ones. The DEC VAX, and the ICL 2900 series, which, anybody know about ICL 2900s? Yeah. That's in development, but I've got quite a long way with that. The original SimH was written by a guy called Bob Subnik, who designed actually one of the VAX CPU chips. He knows what he's on about, and he's very, very good. Other emulators by various other people. There's been a bit of a problem recently because somebody else started up on GitHub a new version of SimH with lots of new enhanced features, and it worked very well. Lots of people contributed. And then this guy suddenly closed the source to some of it and started putting copyrights on it. And people got very annoyed that effectively stuff they contributed to had been copyrighted. So they basically broke away from him, and he's on his own now. There's a new project called OpenSimH. So that's the one you need to look for, all right? But in fact, Bob Subnik's original SimH is still the one that I use. It's on a site called trailingedge.com, as opposed to leadingedge.com. And you can put SimH on the Raspberry Pi quite happily. And in fact, that is what is done with some of the later emulated hybrids. But you could use an Arduino or an ESP32 if you want to get out to the hardware level, or you can use a PC, and whatever you like. So this is one of Oscar's slides. This is his PDP-8i. He calls it a PiDP-8, and it's got a Raspberry Pi inside it and a board carrying the LEDs. And it's built into a nice wooden box. The wooden box can be bought from Amazon. It's actually a kitchen storage box. And it's about 60% of the size of the real PDP-8. So it's got all the nice switches, it's got the right colour. You have to have the switches made especially because they weren't the right colours. And he wanted it as authentic as he could. But you can see it's got the same front panel, it's got the little list of the bootstrap instructions, everything's there. Right, so you can see a more detailed thing about the ROM loader, what they call the RIM loader, that's read-in mode. And it's got, you can use a Pi 0 if you want, but the 2 is better. You probably don't need a Pi 4 and all that heat, power, and the cost. I mean, Pis are ridiculously expensive now. You can build your own, or you can buy a kit, and he sells kits to make these, right? They're not very expensive, and they're a little bit tricky to build, but you know. So what was it? He designed this PiDP-8. He decided to do it by just looking at what people would want. They want the experience of playing with a real old computer. So, first of all, it's got this rather interesting thing. There are more switches than you need for bits in the machine. It's a 12-bit machine. But there is a set of switches there, which when you start the thing up, decide what it's going to load from. So it can load from paper tape and be a naked machine. It can load from deck tape, the OS8 system, or it can load from DES. It can run TSS8. It can run something called ETOPS, which is not very well known, and it can run Space War. It's important. Okay. So you can do all that, but you have to store these somewhere. So what do you do for an emulated paper tape? You put it on a USB stick. And he even managed to make the USB sticks look like proper deck things. So it's rather nice, yeah? So it's also got to be pretty. It should have an existence in the living room. Some wives might disagree. Or indeed husbands in some cases, because I have seen that. It's the woman who's actually the enthusiast and not the husband. You can have a real terminal or teletype or log in over Wi-Fi. Wi-Fi makes it a lot easier and going to do all the casing thing. It's going to be somewhat useful. You can use it as a Raspberry Pi at the same time, because it's a multitasking system. It's actually running Linux in there. As a PDP-8 with up to 6 users if you're running the right thing. And it could even be a decorative Wi-Fi router if you wanted it to be. But that's quite silly. So what's the hardware? This is the main board in it. That's the whole board there. What we have here are the two bits, the Raspberry Pi bolted onto the one side of the board. And I can sort of show you the bits. So the Raspberry Pi is there. You've got 89 LEDs, which take a while to solder, and 26 switches, and they've got about 4 connections each, because 2 are for tabs for holding it in place, and the other 2 are the actual electrical connections. 26 diodes and 15 resistors, and 1 chip, because you need that to run all the LEDs. So it's not too bad to build. You know, if you're competent at soldering, it's okay. The switches are the trickiest part. So the software is a Simh emulator. It's, I think, the best PDP-8 you can get. There's one called Win8, by the way. That's WINEIGHT, and you could look for that as well. But it's the lowest cost. And the emulated PDP-8 has got some extra bits, so it's connected to the front panel hardware, so it works the lights. And it sends out the contents of the registers on logic lines, and you can actually use those to display them on the front panel. And at the same time, the front panel is updated 60 times a second. There is a version of that which actually doesn't put the LEDs on fully. It gradually ramps up the voltage and down again, so they look like incandescent lights glowing. So somebody's gone to a lot of trouble, extremely sad. You can have terminal access via the network. You can have a network socket on it, which I'm planning to do, or you can use hardwire it. But you just can use Telnet or SSH or something. So it's a kit, and this is the kit. What you've got there are, I think it probably says, a kit means that when he was designing it, he had to make sure it was easy to do, and doesn't require a lot of precision. So I'll skip over that here. It's the justification for the kit, but the picture here is what you've got. So you've got the case, you've got a piece of wood which is needed for mounting the board, the chip. I forgot what that was, the connector, that's right, and then just these various things like resistors of 89 of them, 25 of them, whatever, you know, and then another little board, the main board, and the front panel. That's it, and you just put it all together, and you've got a working PDP-8. Other projects, there's something called a PyDP-11, the 1170, which is one of the bigger machines, and I've got the kit for that, but I haven't had time to build it yet because I was too busy writing another emulator. There's a PyDP-10 in progress, which is I really want. But when lockdown happened, the pandemic happened, Oscar, who lives, I think, in Switzerland, had some, I think he had a bit of mental problems for a bit with being cooped up, and he couldn't get anything done anyway. So he rather sort of, it all stopped for a couple of years, but he's got going on it again. He realised that rather than the boxes, we should have injection moulded cases. And he did that for the PyDP-11, and he's decided now to do that for the PyDP-10. And he's done a first pass through the factory to try and get a prototype, and that seems to be okay. But he also did anyone come across the Kim-1, which is an old computer, the Amiga 88, the Altair Arduino, you can guess what that is. and various other obscure computers. So there's your Altair one. And you can look at virtual ones as well on retrocomp.org. It's got some interesting stuff. But hopefully you can revive other important machines. I mean, as more machines get old and disappear, not everything is a PC even now. You can start playing with some interesting things. So future work, just for Simh, as I said, there are others, and it would be nice to build panels for more of them. I'm looking at building a panel for the Honeywell 516, because that will be quite a nice one to do. As I said, I worked on that many years ago. There was an interesting thing about that, and I'll tell you in a minute. The PDP-10 is a challenge because there are so many lights, you haven't got enough input-output. That's a PDP-10 console. So you'd be emulating that. And there are not that many lights because there are only 2 or 3 rows, but the sheer number of switches is ridiculous. So yes, that's going to be, it's been done. I would like to build one for the Honeywell DDP-516. That's what it looks like. It's a panel about that big. That's the bit that sits on your desk, and then you've got the cabinets behind it. Big cable, as you can see. Now, I wanted to get the precise measurements of the DDP-516 panel, like this. And I found this picture, and I thought, well, I wonder where that is. It's in the Science Museum. That's actually a Science Museum picture. And they've got a complete, well, they had a complete 516. The only bits on display is that. So after 5 months of negotiation, they let me go up very early one morning. I had to be there at 7:45. And they said, yeah, come in and you can take whatever measurements you like. They pulled it out of the case for the cabinet. They had to get their smallest employee to crawl into the display case to get it. But the best bit was they'd taken it down to the lab. And I got down to the lab and I sat down with it and I put my hands on it and I said, it's the first time I've touched this in 44 years because it was the same one. I knew it was the same one because what happened to it after Kent got rid of it in about 1980 was it was donated to Simon Langton Boys. And they donated it to the Science Museum about 5 years later. So this one was actually gobsmacked. And I said, look, it's still got that bit of tape on the side. So yeah, I've mentioned all that. So yeah, work is currently underway. I'm producing emulator software for the ICL 2900, which is a large mainframe computer with all sorts of virtual memory stuff and everything else. And we had one for 10 years at Kent, and I looked after it. That's an ICL 2960. You see the sheer size of the thing. That's not all of it. All we have there is a control console. That's the engineer panel, and the rest of it's a CPU and memory. There's not a disk controller in there. There's not a peripheral controller in there. There's not a comms controller in there. They're all in separate cabinets you can't see. So it's a big thing. And of course, they have to have the photogenic women always, who models brought into the occasion. It's always women working these things. Apart from one I saw where they were talking about how, I forgot what it was, something about air conditioning or something, and they had a picture of 2 women in bikinis in the computer room. But to be fair, they also did have one bloke in Speedos.
Equality.
So I don't think you can do much with the panel for the 2900 because it's got hundreds of lights. I mean, the engineer panel alone. What I have done is an emulation of the engineer panel, which is a 20-line display, 20-character, 7 or 8-line display. I've done the emulation of that in a separate window. So that's just about it. Thanks to Oscar for the kits and with the future kit, which I can't wait for. I've been saving my money. They're really, really complete. They're wonderful. They're good, well documented. A lot of people have got behind it and improved the software too. And he said, of course, I can use the slides, so that's very nice of him. Also, thanks to Bob Supnick, who wrote all the PDP emulations and some of the others in Simh. Bob Armstrong, who's a guy who designed the SPC 6120. The only criticism I have of him is that he always seemed to use chips that were really difficult to get hold of. And some of them, that wasn't necessary because they were newer chips. And to John Todd, who's the chemistry professor who had the mass spectrometer in his garage, who gave me all that documentation at this funeral. So yes. So, conclusion, just simply, playing with this stuff is great fun. It's hard to get real computers. You can make a replica, but you may have trouble with some of the chips there as well. But you can always build it. Emulation is easy. You can go out now or tomorrow, and you can download the PDP emulator and start running, as I say, easily. If you want some display hardware, in other words, pretty lights and things, that's going to cost you a bit more. So have a go, is what I'm saying. Okay, questions. I've got one more slide after this, but that's really just for reference. So I think if I could ask for questions, that's...
Yeah. So for anyone that doesn't know, Bob was one of my lecturers at uni, so I know him. So I was just wondering, sorry, I wrote this down so I don't forget. As an ex-lecturer, how important do you think it is to explore old hardware? Do you think it shapes the kind of programmer we become?
I would like to see more hardware done than has been done in recent years. We used to teach assembly language to all computer science students.
What year was that?
Well, from about 72 on to about 1985, something like that. And then they said, oh, do a teach assembler, don't use it anymore. It's hard to write reliable programs with it. That isn't really the point. I think you need to know where you've come from. So, but then we went back on to doing it. There's a guy called Fred Barnes, who's another former student. You know Fred Barnes? Yeah. He actually reinstituted teaching assembler on a more modern chip, on a microcontroller chip, and actually has had computer science students doing a little bit of hardware and soldering and everything else. And he was still doing that when I left in 2015. But since he also got pissed off with the department, he left a year later. I don't know what's happening now, but I suspect very much it's not happening, which I think is a shame. And that then brings you on to at least how things work at the lower level. I think machine architecture is still taught. So you get an idea of how these things work internally, but you don't get to play with any, which is a shame.
Depends where you go, really. I believe Queen Mary still has a embedded systems course where you do actually get to play with microcontroller boards. It's an optional module in the final year, but it is quite popular, or at least it was when I did it.
Yeah, I think Kent certainly did have an embedded system thing, but I think that guy was teaching it. But there is
one person in charge.
There is a course in the engineering department, which used to be the electronics department, which does that kind of thing, and they've got a master's that does that. So you can go there and do a master's for next year and learn about your embedded stuff, which is another way. Anyone else?
No, I was just saying, I think back to my A-level, I did assembly language programming on, I think it was a Commodore PET, 6502 processor, but soon after that, I don't remember it ever being taught again. It's just
I mean, 6502, the thing was about, this guy actually did that for A-level, he used a 6502, and 6502 is the one they had in the BBC Micro.
That's right.
I had to do some work on a BBC Micro ROM once, so I had to learn 6502 assembly. But learn one assembly, you've learned most of them. Not entirely, but once you've got the concept, it's very easy to learn a new one. And there are very few that are way out in a different concept. So it's very, very quick to learn a new one. And that's true of programming languages too, actually. If you learn, there are only about 5 different types of programming language. Learn one of each of those and you're home, basically. Where it gets difficult is when you learn something like, Prolog. Because Prolog's completely and utterly different to most other things. But you can do some very clever things with it. Yeah?
You said that there were, you could run your mass spectrometer or whatever it was, hardware off one of these machines, but how easy was it for those people to get hold of one of these computers and integrate it into the tasks that they wanted?
Well, very engineering. Okay, so the question is, how easy was it to integrate?
That's exactly what I said.
Yeah. How easy was it to integrate the PDP-8 or whatever with your mass spectrometer or whatever it happened to be? The answer is that DEC were very engineering based, and they would publish everything you needed to know. They would, for a fee, help you, and you usually had somebody locally who was a technician who would know enough about this stuff to get to the other end. They sold interface boards of various sorts, analog and digital interface boards, so you could do most of your stuff with that fairly easily.
I actually have a couple of questions. Did anyone try to run Unix on a PDP-8, or do you need a PDP-11?
Well, first of all, Unix came later, but it's not big enough, really. It only just fits on a PDP-11. Unix. The question was about running Unix on a PDP-8. The PDP-11 is barely big enough to run Unix. Unix version 6, 6th edition, which was the first one that really came out of Bell Labs properly, would fit on a PDP-11. But if you added any new device drivers or anything else, then you ended up reducing the amount of I/O buffers, because that's the only way to get the memory back. And if you did that, then it would run slower. And Unix version 7 would not run on a basic PDP-11 at all. Having said that, if anyone's interested in the sort of minimal Unix on PDP-11, there's a version of Unix that doesn't use memory management that runs on a basic PDP-11 called Mini Unix, which is not well known. And if you go onto my webpage, you will find there's no, it's actually on another of my web pages, but I can give you the link. It's actually, I've got the complete thing where you can have the full experience of installing Mini Unix from a tape on Simh and then running it, and all the documentation too.
Thank you very much. And my second question was, looking at the front panels for the PDP-8, there's just this intrusive thought we say, that looks like a drum machine. Has anyone actually used it as a drum machine?
I don't know, but you could. You could use it as a drum machine because it's got the interfaces and everything else. I mean, harder to do with modern stuff. But remember, of course, if you're running with a simulator, you can bring anything else out that you like outside and make it work. The biggest problem will be that Raspberry Pi has only got a certain number of GPIO pins. What I cut out of this talk today, partly from time and partly for other reasons, is that it's actually really, really hard to get all those switches and all those lights multiplexed down what is essentially about 18 pins on the GPIO of a Raspberry Pi. And he did it, for those who know about these things, by using tri-states and some clever stuff. The switches and the lights actually share the same I/O lines, and it's really, really tricky. With the PDP-10, or PDP-10, what he's had to do apparently is have a separate chip to handle that. It's a standard chip, but you know it has to handle all these. It's a microcontroller, and it's programmed to handle all the right things. Anyone else? Right, I'll just flip on to...
One really silly question. You mentioned something about the computer with the loudspeaker.
Yeah.
And you said something about, how you liked it being higher up because then you could hear when it broke.
Yeah.
How often did it break? Well, that's been something you remembered. Was this a common thing?
Well, it depends which operating system you're talking about. I mean, we had this RCL 2960 from 1976 onwards, and it was the Windows Vista of operating systems. It was terrible. I can tell you that what we used to do was we used to record a rolling average of MTBF, mean time between failure, of both hardware and software. And the rolling average was over 13 weeks. And we only ran it during the day. The rolling average of mean time between failure was 22 hours. Right? Which for a mainframe that's running, basically running a student service, if it crashes, you've lost part of a student class. And a lot of these classes have people from different degree programs. You can't timetable an alternate class. There's no way. So it was a real problem for us. And yes, I wasn't heavily involved in that system, but when we moved to the replacement system, the one from Edinburgh, I was in charge of that, and we probably got an MTBF of about 2,000 hours, and that was entirely hardware. I think we ever had a software crash, right, in the 7 years we ran it. Entirely hardware. I could give a talk on that operating system, but I don't know whether that's a good one to do or not. I'm going to get, Alex is going to look at it, and I've got a video of it, and see whether or not it would be something I could cut down to size and do here. But it was very reliable. But if I was testing stuff out, then, or I knew that the hardware was faulty, then I could hear the loudspeaker, and it's connected to one of the jump instructions. That's how it works. Very common in older computers to have a speaker like that. And you're not actually as clever as it sounds, because what you're listening for is a pattern. and you recognise the pattern of something which is going to be a clash, and that's all you do. You can tell when it's working hard because the pitch changes and things like that. That's good fun. Anyone else? Right, one last thing then. His references. This is, you can contact me at bob@eager.cx. It's easy to find. And on there, there's also bobeager.uk. And that's got a projects page which shows you pictures of the, it's got extended version of the slides here. It's also got pictures, more pictures of the replicas I showed you. The PyDP website, where you can sometimes order a kit. He's not doing PyDP 8 kits at the moment. And documentation at bitsavers.org. You probably know about bitsavers.org. But yeah, any questions, just send me an email at bob@eager.cx and I can answer it for you. I'll leave that up anyway. So.
Thank you.